Listen, students, is an important question. Common drain amplifier. It is also called as source follower. See this diagram. Now, common drain amplifier output is taken in the source. Output is taken in the source means it is called as common drain. Suppose we take output in the drain terminal, that is called as common source. Okay, clear? Source output is taken in the source, that is called as common drain. Output is taken in the drain, it is called as common source. See here, output is taken in the source. Output is taken in the source is called as common drain amplifier. Okay, right. This circuit output is taken in the source, no, hence it follow the source. Output is taken in the source, hence the entire circuit is follow the source. That's why it is called as source follower. So இது வந்து உங்களுக்கு தெரிஞ்சுக்கணும்னு நினைக்கிறேன். Okay, first என்ன சொன்னேன், output is taken in the source, that's why it is called as common drain, right? Then the circuit follow the source because output is taken in the source, no, so circuit follow the source, also is called as source follower, right? Then now we draw the small signal model for this. Small signal model, see here, that is how we draw the small signal model. This is your source, then this is your source resistance RS. இது நாங்க போடல, நீங்க போட்டுங்க. Okay, source resistance RS. Then R1 R2 எப்படி எடுத்துருக்காங்க, see here, உங்களுக்கு the procedure தெரியும் இல்லையா? We know the procedure. To draw the small signal model, disconnect from the supply. Are we clear? Disconnect from the supply and connected to the, disconnect பண்ணிட்டு என்ன பண்றோம், connected to the ground terminal. Here also disconnect from the supply and connected to the ground terminal. Okay, so ground ல என்ன வருது, this is your R1, then this is your R1 இல்லையா? Okay, this is your R1, then this is R2, RS, RD, everything, right? Now in this, these are the important thing. I0 is equal to ID, that is output current is ID. I0 is equal to ID. Then V is equal to Ohm's law, I0 into R0. V0 is also output, right? No, I0 into RS. Next one, VS. What is VS? IS into RS. Listen here. So this is your VS. So this is your VS, right? What is this VS? We know that V is equal to I into R. What is I? I is equal to IS. What is R? R is equal to RS. So VS is equal to IS into RS. VS is equal to IS into RS. Then the current here is ID, no? The current here is IS. This IS is approximately equal to the current ID. ID is a drain current, right? ID. So this ID is approximately equal to IS. Then what is ID? ID is nothing but GM into VGS. Normally, what is I? I is equal to in Ohm's law, V is equal to IR, I is equal to V by R, right? I is equal to V by R. Now listen, so this V is VGS. Then what is R? R is nothing but 1 by GM. What is GM? GM is the conductance, so G is equal to 1 by R. That's why என்ன பண்றோம் V by R வரதுக்கு பதிலா instead of by R we put a GM, so ID is equal to GM into VGS. These are the formulas. Kindly remind this formula. These are the very important, not formulas, parameters we are used in this derivation. I is equal to I naught is equal to ID, V naught is equal to I naught into RS, Vs is equal to Is into RS, Is is approximately equal to ID, then ID is equal to GM into VGS, right? Any doubt in this? Yes? Now it's clear? Okay. Then, so same thing, there's a source resistor RS, then the resistance is disconnected from the supply and connected to the ground terminal is R1. Next one is R2. See here, in this, device is not directly connected to the ground. Device is connected through the resistor. Yes, this is your device. This is your device. This device is not directly connected to the ground. This device is connected to the ground via this resistor. Okay, so small therefore in small signal model JFET also not connected to the ground, connected to the resistor. Okay, now see. Yes, yes, this resistor. Are you clear? This is the resistor. Then above this resistor, JFET small signal model is present. What is small signal model? One resistor, one current source, one resistor. I already told. What is normal small signal model is nothing but one resistor, then one current source, then one resistor. Normally, this is a small signal model. This is a blind method. Okay. What is that? One resistor, one current source. Current source means we are indicating the direction of the current, right? Another one is one resistor. So here also, what is the first resistor? First resistor is your input side, no? So this is your gate resistor RG. Then output device impedance RD. Then what is the current? This current is nothing but ID. That's current. So what is the current? Current is nothing but ID. What is ID? ID is equal to, we know that ID is equal to GM into GM into VGS, right? GM into VGS. This is your ID. ID is equal to GM into VGS. Okay. So this is your RG, GM into VGS and RD. Right. Now, listen here. In this, the input is VI. Input is VI. This input is divided, dropped this across this resistor and across this resistor. Okay, this is your input Vi. Now this Vi is dropped across this resistor and dropped across this resistor. So what is Vi? Vi is equal to VGS this drop. Okay, then VGS plus VS. What is VS? This drop. Okay, right. Now what is VS? We know the formula. VS is equal to IS RS, because the current through the resistor is IS. Then what is the resistor? Resistor is equal to RS. VS is equal to IS into RS. Then in parallel voltage is constant now. So we are putting VS is equal to V naught. VS is equal to V naught. Then listen, IS is equal to ID. We know that no? IS is equal to ID. Okay, what is ID? ID is equal to GM into VGS. That's all. VI is equal to VGS plus VS. VS is equal to IS into RS. IS is approximately equal to ID. So ID into RS. Then VS is equal to parallel voltage is constant. No? Okay. This ID is equal to GM into VGS. Then after that, VS is equal to V naught. This VS is equal to V naught. புரியுதான்னு பாருங்க. VI is equal to this drop plus this drop. What is this drop? VS. What is VS? IS RS. VS is equal to V naught. This IS is approximately equal to ID. What is ID? GM into VGS. Okay, see here. Any doubt in this? Okay. And we'll move the next one. Very, very simple derivations. We are using only Ohm's law. Right? Now, we find out we find out the three parameters. One is your input resistance. This is input resistance Zi. Next one is the output. Third one is voltage gain. That's all. We find out Z input side, Z impedance in output side, then the gain AV. Then listen, this input side resistance Zi. This is also classified as two types. What is the two types? One is Z I C. That is input impedance for circuit. Another one is Z I D. What is that? Input impedance for load. Here also same way, output also classified as two type. What is that? One is output impedance with the circuit. Another one is output with the device. That's all. So impedance, first we find out three parameters. What is that? Input impedance, output impedance, voltage gain. This input impedance is classified as input impedance for circuit and input impedance for device. This is D, right? Next, output impedance for circuit, output impedance for device. Third one is voltage gain. Okay, right. Now see here, here also they tell same thing. Zi is your input impedance. This input impedance is classified as ZID and ZIC. What is ZID? Device. ZIC for circuit. என்ன பண்ணிருக்காங்க இங்க சொல்லிருக்காங்க, what is that? Zi is nothing but input impedance. Zd is nothing but Zid is nothing but input device impedance. Zic is nothing but input circuit impedance. Have you clear? Right. Now listen, ZID. What is ZID is nothing but device input impedance. What is the device? Device is nothing but only ZG. That is gate. வேற எதுவும் இல்ல இல்லையா? This is ZIG. Now see here. Now we find out the ZG. Okay. What is input impedance? Input impedance is equal to input voltage. Okay. input voltage divided by input current. நல்லா தெரியும் நம்மளுக்கு Z is equal to R is equal to V by I தானே. So Zg is equal to V by II. Now listen, we know that what we know VI is equal to VGS plus VS. Now முதல்ல பார்த்தாச்சு இல்லையா. Now VGS அப்படியே இருக்கட்டும். Now what is VS? VS is equal to IS into RS. RS எங்க இருக்கும்? parallel RL வரும் இல்லையா, அதான் போட்டுருவாங்க. VS is equal to IS into RL. See here இந்த சர்க்யூட் போட்டுருவாங்களா. VS is equal to parallel வருது. what are resistance? RS parallel RL. See here. Now so Vs is equal to Is into Rs parallel RL. Then we know that Is is equal to Id. So instead of Is we put Id. What is Id? We know that Id is equal to Gm into Vgs. So Vgs plus Id is equal to Gm into Vgs, Rs parallel RL. This is your Vi equation number 2. புரியுதான்னு பாருங்க. So input impedance சொல்லியாச்சு. Input impedance is classified as device impedance and circuit impedance. Then Zg is equal to input voltage by input current. Suppose you are not able to follow the steps, it's not a problem. Just strike out that. வேற பாருங்க. ஓகேவா? இப்போ இந்த ஸ்டெப் புரியுதா? Zg is equal to input voltage by input current. Now what happened? Same thing. Vi is equal to, we know that Vgs plus Vs is equal to Is into Rs parallel RL. Then Is is equal to Id, everything. Then Id is equal to Gm into Vgs. Finally, you got this equation. Yes? Purida? Then, I'll go to the next one. Next one. So listen, இங்க என்ன கண்டுபிடிச்சோம் நம்மளுக்கு? V மட்டும் கண்டுபிடிச்சாச்சு இல்லையா? We find out only Vi. Now what we do? Zi is equal to Vi by Ig. That is Z is equal to V by R. What is Vi? Just நம்ம என்ன பண்ணலாம்? Substitute பண்ணிடுவோம். போச்சா முடிஞ்சு போச்சு. என்னது? Vi is equal to direct substitute பண்ணிடுங்க. Then after that, what is II? II is nothing but Ig. போட்டோம் இல்லையா? I is nothing but Ig. What is Ig? Ig is equal to Vg by Rg. Now இங்க பாத்தீங்கன்னா இருக்கு, this is your Vi value. This is your Vi value. Already we find in the equation 2 ல பார்த்தோம் இல்லையா? Equation 2 ல பார்த்திருப்போம். This is your equation 2 ல பார்த்திருப்போம். என்னது? This is your Vi value. Then what is this? This is your Ii value. Ii is equal to Vg by Rg. Now listen. This is nothing but Vgs. What is Id? Id is equal to Gm into Vgs. Then Rs parallel RL. Here is this Vg by Ig. Is nothing but Vgs. Now you take Vgs common. Then Vgs get cancel. You got a resistance, impedance. Zg is equal to what happened? This is nothing but this is Rg. Okay, change this. This is Rg. So Rg மேல போய்டும் இல்லையா? அப்ப என்ன? Rg is equal to this is your device or input impedance. Then what is circuit impedance? Circuit impedance is nothing but we are adding two resistors parallel R1. Initial வருது இல்லையா? R1 parallel R2. That's all. So Rg value is very very high. In parallel combination, what happened? I value means negligible. So Zi is equal to, this is your Zic. Zic is equal to R1 R2. This is your Zi D. புரியுதா? பாருங்க. Yes. This equation 2 வரணும் இல்ல? This equation 2 இருக்கு இல்லையா? இந்த equation 2 நம்ம என்ன பண்றோம்? Substitute பண்ண போறோம் அவ்வளவுதான். We are substituting the equation 2. Then this is your Ia, no? Ia is equal to V by R, Vg by Rg. Then finally you got this answer. Right? This is parallel combination. Okay? Parallel combination, high value is negligible. Then circuit output impedance. Listen here. This is your circuit output impedance. This is very very important. நம்ம அதே சொல்லியிருப்பேன், உங்களோட ஒரிஜினல் அவுட்புட் தெரிஞ்சா என்ன பண்ண முடியும்? பேக் சோர்ஸ் எல்லாத்தையுமே எடுத்துடணும்னு சொல்லுவேன். அதாவது சோர்ஸை ரிமூவ் பண்ணிடணும் இல்லையா? ஸோ சோர்ஸ் இஸ் ஈக்குவல் டு 0. அப்போ என்னாவது? V naught by ID, output voltage by output current. அதாவது output current வந்து I naught by ID. Now what happened? We know that VI is equal to VGS plus V சொல்லுவோம் இல்லையா, சேம் திங். இப்போ என்ன ஆகுது? VI is equal to 0. Now what happened? V naught is equal to VGS. இங்க மைனஸ் வந்து பார்க்காதீங்க, you put plus also, it's not a problem. So VI is equal to VGS plus VS. VS is equal to V naught சொன்னோம்ல. So V naught is equal to VGS. எங்க சொன்னோம்? VS is equal to V naught. இங்க பாருங்க. See the diagram. What is this? This is your VS, right? This is your VS. This VS, then this V naught, both are in parallel. You know that parallel combination voltage is same. So VS is equal to V naught. அதாங்க போட்டிருக்கோம். Okay. See here, VS is equal to V naught. Now V naught is equal to VGS. இங்க ஏன் வந்து பிளஸ் போலனா மைனஸ் சிம்பிள் வரக்கூடாது இல்லையா? That's why we changed it plus into minus. Okay. So V naught is equal to VGS. Now we know that V naught is equal to what happened? What is V naught? V naught is equal to, sorry, what is Z naught? Z naught is equal to V naught by ID. What is V naught? V naught is equal to VGS. V naught is equal to VGS, right? Super. V naught is equal to VGS. Now listen, divided by what is this? ID. Divided by ID. What is ID? We know that, what is ID? ID is equal to, you know the formula, ID is equal to GM into VGS. So என்ன பண்ண போறோம்? Just you substitute this value to ID. You substitute this value to ID. Now what happened? VGS will cancel. Finally we get a 1 by GM. See here. Finally we get, what is the answer? 1 by GM. Understand? This is your VGS. This is your ID. 1 by GM. Parallel RS, parallel RD, that is circuit. Okay. This is for device. This is for circuit. We are adding parallel. This means that is circuit. This is the device. Okay. So input impedance is over. Output impedance is over. Then finally, what is that? Voltage gain. Finally, voltage gain. What is voltage gain? Voltage gain is nothing but output voltage divided by input voltage. What is output voltage? V naught. What is the input voltage? VI. So V naught is equal to V equal to I into R, no? So I naught into RS. Then VI is equal to same thing, VI. Now listen, I naught, what is the current? We are taking output in the source, no? So I naught is equal to IS. Now IS is approximately equal to ID. That's why I put ID. Output current is ID, right? Output current is ID. So இங்க என்ன பண்ணுங்க, நீங்க just இங்க போட்டு ID கூட போட்டுக்கலாம். It's not a problem. Okay. Output current is I naught. What is I naught? I naught is equal to ID. What is ID? ID is equal to GM into VGS. You know, no? ID is equal to GM into VGS. What is VI? Already in equation 2 we see what is VI. So just substitute the value of VI. Okay, then substitute the value of ID. ID is equal to GM into VGS. Now what happened? Now this VGS and this VGS will be cancelled. So output is equal to GM by 1 plus GM into RS parallel RL. Now listen here. So this value is very, very high. This value is very, very high. Now 1 will be neglected. Now finally you got which answer means see here. Okay, see here. This is approximately equal. This is -1 plus GM is approximately equal to Gm into Rs plus RL. So in numerator also Gm into Rs parallel RL, numerator also RL, denominator also Gm into Rs parallel RL. So I'm substituting. What I got means I get cancel this and this are cancel. Now what is the output means? AV, voltage gain, is the unity gain. Voltage gain is the unity gain. In transistor collector, common collector is unity gain. In this JFET, what is that? Common drain is unity gain. அதான் ஆல்ரெடி சொல்லியிருப்பேன். பிராக்கெட் அங்கே என்ன இருக்கு? எமிட்டர்னா in transistor, emitter, in transistor, emitter is similar to source in JFET. Then collector is similar to drain. Then base is similar to gate. So, okay, so here also the voltage gain is unity, hence common drain, the voltage gain is unity. This will be proved. This is your 16 mark question, 13 mark question, common drain or source follower. திரும்ப சொல்றேன், why it is called as common drain? Output is taken in the source, so it is called as common drain. Then if the output is taken in the source, no, so entire thing is follow the source. That's why it is also called as source follower. Whatever it may be, common emitter, the gain is unity. So common drain, the gain is unity. So the common drain is also called as source follower. Anyway, any doubt is there, kindly call me. I'll clear the doubt or I send the mail. Thank you. Thanks for listening. Thanks for watching. Thank you.